July 1941, Eastern Front. A German panzer commander crouches inside his tank, sweat dripping down his face despite the morning chill. Through his periscope, he watches something that shouldn't exist. A Soviet tank races across the battlefield at impossible speed, its sloped armor gleaming in the early light. He gives the order to fire. The shell strikes dead center, but instead of penetrating, it ricochets off the angled armor like a stone skipping across water. His gunner fires again, and again. Nothing. The Soviet tank rotates its turret with mechanical precision and fires once. The German Panzer III erupts in flames. The commander barely escapes, stumbling into a ditch as his crew screams behind him. He radios headquarters, his voice cracking with something German officers rarely show. Fear. We cannot stop them. Our guns are useless. What is this machine? But this nightmare didn't begin on a battlefield in Russia. It began 11 years earlier in a cluttered workshop in New Jersey, with a man nobody would listen to. His name was J. Walter Christie, and the tank that was terrorizing the German army? It started as an idea America threw in the trash. The year is 1919. The Great War has just ended. Europe lies in ruins, its fields scarred by trenches and barbed wire. A new weapon has emerged from the carnage. The tank. Slow, unreliable, barely faster than a walking man, but undeniably powerful. Military planners across the world are trying to figure out what to do with this lumbering beast. Most see it as mobile artillery, a way to support infantry as they advance across no man's land. Slow and steady, armor and firepower. That's the consensus. But J. Walter Christie sees something completely different. He sees speed. He sees mobility. He sees the future of warfare, and it's moving at 70 miles per hour. Christie isn't your typical military contractor. He's a former automobile racer, a self-taught engineer with grease under his fingernails and fire in his eyes. Born in 1865 in River Edge, New Jersey, he grew up in an era of rapid technological change. He watched the automobile transform from a curiosity into a revolution. He didn't just watch. He participated. He built race cars that broke speed records. He designed front-wheel drive systems before most engineers thought they were practical. He patented innovations in automotive suspension that made cars faster and more stable. He's a man who looks at conventional wisdom and asks one simple question: why? During the Great War, Christie watched the development of tanks with intense interest. The British Mark series, the French Renault FT, the German A7V, all of them slow, ponderous machines. The Mark V could barely reach 5 miles per hour. Even the lighter Renault FT topped out at 7. Christie, who had built cars that exceeded 100 miles per hour, found this absurd. Why should an armored vehicle be slower than a horse? Why should mobility be sacrificed for protection? In his workshop, surrounded by blueprints and half-assembled prototypes, Christie is working on something revolutionary. Not just a tank. A new concept of what a tank could be. His M1919 prototype sits in the center of the space, looking nothing like the boxy, slow tanks that crawled across French battlefields. It's sleek, it's fast, and it has a feature that makes military observers shake their heads in disbelief. It can remove its tracks and drive on rubber wheels like an automobile. Christie's logic is simple, almost obvious to him. Tanks are slow because they're designed to cross trenches and rough terrain. But what about the journey to the battlefield? What about strategic mobility? Why should a tank crawl at 15 miles per hour on roads when it could race at 70? His solution? Large road wheels with independent suspension, allowing the tank to either use tracks for cross-country movement or remove them entirely and drive on pneumatic tires for high-speed road travel. The engineering is elegant. Each road wheel is independently sprung, using long helical springs mounted inside the hull. This allows each wheel to move up and down independently, absorbing shocks without transmitting them to the entire vehicle. The result is a smooth ride even at high speeds over rough terrain. The large diameter wheels, much bigger than those on conventional tanks, reduce ground pressure and improve obstacle crossing ability. When the crew removes the tracks, the tank can drive on its road wheels using rubber tires, transforming it into what is essentially an armored car capable of highway speeds. It's brilliant, it's innovative, it's decades ahead of its time, and the United States Army wants absolutely nothing to do with it. Christie approaches the Army Ordnance Department with the confidence of a man who knows he's right. He demonstrates his prototypes. He shows them the speed trials. His M1919 reaches speeds that astound observers. He explains how his suspension system allows the tank to absorb shocks that would shake apart conventional designs. He talks about the future of warfare, about mobile cavalry units that could strike deep behind enemy lines, about the end of static trench warfare. He envisions armored divisions racing across continents, outmaneuvering enemies, exploiting breakthroughs with speed that makes defense impossible. The officers listen politely. Then they reject him. Too radical, they say. Not practical for mass production. The convertible track system is too complex, too prone to mechanical failure. And besides, the Army doesn't need fast tanks. They need reliable infantry support vehicles. Slow, steady, predictable. Christie's designs are interesting, they admit, but not what America needs. The rejection stings, but Christie doesn't give up. He refines his designs. He builds the M1921, improving the suspension, making the conversion system more reliable. The new prototype is even faster, even more capable. He demonstrates it again at Aberdeen Proving Ground in Maryland. Army observers watch as the tank races across the test course at speeds no military vehicle has achieved. They take notes. They ask technical questions. Then they reject him again. The reasons vary. Sometimes it's the cost. Christie's designs are expensive to produce, requiring precision manufacturing and high-quality materials. Sometimes it's reliability concerns. His early prototypes do have mechanical problems. The track conversion system is finicky. The suspension, while revolutionary, requires maintenance. Sometimes it's simply institutional inertia. The Army has invested in conventional tank designs. They have training programs, maintenance procedures, tactical doctrines all built around slow infantry support tanks. Christie's fast tanks would require rethinking everything. But there's another factor, one that becomes increasingly important as the years pass. Christie himself is difficult to work with. He's brilliant, but he's also stubborn, argumentative, and utterly convinced of his own correctness. When Army engineers suggest modifications to his designs, he refuses. When procurement officers ask him to meet certain specifications, he argues that the specifications are wrong. He doesn't compromise. He doesn't collaborate well. He insists that his vision be implemented exactly as he conceives it, or not at all. In the conservative, hierarchy-driven world of military procurement, this is a fatal flaw. The Army doesn't just want good technology. They want contractors who follow orders, who work within the system, who don't cause problems. Christie causes problems. He writes angry letters to congressmen. He publicly criticizes Army tank policy. He accuses military officials of incompetence and corruption. He may be right about the technology, but he's making powerful enemies. Christie builds the M1928, incorporating further improvements. He demonstrates it. Rejection. He builds the M1931, his most refined design yet. Rejection. The Army does purchase a handful of his tanks for testing. They sit in depots, occasionally driven, occasionally studied, but never adopted for production. Meanwhile, contracts go to other manufacturers producing conventional designs. The Rock Island Arsenal produces slow, reliable tanks that fit Army doctrine. Private contractors like Marmon Harrington get orders. Christie gets rejection letters. By 1930, Christie is frustrated, nearly broke, and watching his revolutionary ideas gather dust. He's in his mid-60s, an age when most men are thinking about retirement. But Christie can't let go. He's poured his life savings into his prototypes. He's mortgaged his property. He's dedicated years to perfecting his designs. And America, the country he's trying to help, doesn't want what he's offering. The Army has made its position clear. They're not interested in fast tanks. They're not interested in Christie's vision of mobile warfare. They're certainly not interested in dealing with Christie's difficult personality. But someone else is interested. Someone who's been watching very carefully. Someone who sees exactly what Christie sees. The future of armored warfare. And they're willing to pay for it. In 1930, representatives from the Soviet Union approached J. Walter Christie with a proposition. They've been following his work. They've read the technical papers he's published. They've heard about the Army's rejections, and they see opportunity. The Soviet Union is in the midst of massive industrialization under Stalin's 5-year plan. They're building factories, training engineers, and desperately trying to modernize their military. They need technology, and they're willing to buy it from wherever they can get it. The Soviet representatives are direct. They want to buy not just his tanks, but the rights to manufacture them. They want the blueprints, the technical specifications, the manufacturing processes, everything. They're offering $60,000, a fortune for a man on the edge of bankruptcy. It's more money than Christie has seen in years. It's enough to pay his debts, fund new projects, keep his workshop running. Christie faces a choice. Selling military technology to the Soviet Union isn't technically illegal in 1930. The United States doesn't have formal diplomatic relations with the Soviet government, but there's no law against commercial transactions. However, it's controversial. The Soviet Union is a communist state, ideologically opposed to American capitalism. There's already suspicion, already tension between the two nations. If Christie sells to the Soviets, he'll be criticized. He might be investigated. His reputation, already damaged by his conflicts with the army, will suffer further. But what has America given him? Rejection after rejection, dismissal, mockery. They called his ideas impractical. They called him difficult. They let his genius rot in a workshop while they bought inferior designs from more compliant contractors. The army had their chance. They had years to recognize the value of his work. They chose not to. Why should Christie remain loyal to institutions that showed him no loyalty? Christie makes his decision. He sells. In late 1930, 2 M1940 tanks are prepared for shipment to the Soviet Union. To avoid potential legal complications, the tanks are officially sold as agricultural tractors. The paperwork describes them as civilian vehicles. Nobody is fooled, but the fiction provides legal cover. Along with the tanks, Christie provides complete technical documentation, blueprints showing every component, manufacturing specifications detailing production processes, design notes explaining his engineering choices. The U.S. government learns about the sale and disapproves strongly. State Department officials express concern. Military intelligence officers open a file on Christie, but they don't stop the sale. It's not illegal, just inadvisable. There's talk of changing export laws to prevent future technology transfers, but it comes too late. The tanks are already on a ship crossing the Atlantic. Christie takes the money, pays his debts, and continues his work. He still hopes that someday, somehow, America will recognize what he's created. He continues designing, continues building prototypes, continues trying to convince the army. But the sale to the Soviets has damaged his reputation further. He's now seen not just as difficult, but as potentially disloyal. His chances of ever getting a major U.S. contract have dropped from slim to nearly zero. He has no idea what he's just set in motion. He doesn't know that his rejected design will become the foundation of the most successful tank in military history. He doesn't know that in 11 years, his suspension system will be terrorizing the German army across the steppes of Russia. He doesn't know that he's just changed the course of World War II. He's just a frustrated engineer trying to survive, selling his work to the only buyer willing to pay for it. The 2 Christie tanks arrive in Moscow in late 1930, crated and carefully packed. Soviet engineers descend on them like archaeologists discovering a lost civilization. They uncrate the tanks in a secure facility, keeping the acquisition secret from Western intelligence. They measure every component with precision instruments. They photograph every detail from multiple angles. They test every system, running the tanks through exhaustive trials. They drive them at high speed across testing grounds, watching in amazement as the suspension absorbs impacts that would destroy conventional tanks. They remove the tracks and race them on wheels, hitting speeds no Soviet tank has ever approached. This is exactly what the Soviet Union needs. Stalin's 5-year plan, launched in 1928, is transforming the country from an agricultural society into an industrial power at breakneck speed. Factories are rising across the Soviet Union. Millions of peasants are being trained as industrial workers. The entire economy is being reorganized around heavy industry and military production. Military modernization is a top priority. The Red Army is studying mobile warfare doctrine, influenced by theorists like Mikhail Tukhachevsky, who argue that future wars will be won by speed and maneuver, not static defense. The Soviets have been building tanks, but they're slow, based on outdated Western designs or crude domestic attempts. The T-18, their first indigenous tank, is a small, slow vehicle based on the French Renault FT. It's adequate for infantry support but useless for the kind of mobile warfare Soviet theorists envision. They've purchased and studied British Vickers tanks, German designs, anything they can get their hands on. But Christie's system offers something revolutionary: the ability to move armored forces at unprecedented speeds. The Soviets don't just copy Christie's design. They study it, understand the underlying principles, and improve it. They create the BT series, Bystrokodny tank, which means fast tank. The designation itself reveals Soviet priorities. Speed is the defining characteristic. The BT-2 enters production in 1932 at the Kharkov Locomotive Factory, which has been converted to tank production. It uses Christie's suspension system but is adapted to Soviet manufacturing capabilities and fitted with Soviet components. The BT-2 mounts a 37mm gun and has relatively thin armor, but it's fast. Incredibly fast. It can reach 45 miles per hour cross-country and over 50 on roads with tracks. When the tracks are removed and it operates on wheels, it can exceed 60 miles per hour on good roads. Soviet tank crews, accustomed to slow, cramped vehicles, love the BT tanks. They're exciting to drive, responsive, agile. They feel less like tanks and more like race cars. They're everything Soviet military doctrine says a tank should be: mobile, fast, capable of deep penetration into enemy territory. Production continues with improved versions. The BT-5, introduced in 1933, mounts a larger 45mm gun in a new turret. The BT-7, entering production in 1935, features a more powerful engine and refined armor. Thousands are produced. By the late 1930s, BT tanks form the backbone of Soviet mechanized forces. They participate in military exercises where entire tank brigades race across the steppes, demonstrating the kind of mobile warfare Soviet theorists have been advocating. But combat testing reveals problems. The BT tanks see action in the Spanish Civil War from 1936 to 1939, where Soviet volunteers fight for the Republican side against Franco's nationalists. The BT-5 performs well in the open terrain of Spain. Its speed allows it to outmaneuver nationalist forces. Its 45mm gun is effective against the light Italian and German tanks supporting Franco. But the thin armor is a problem. Anti-tank guns can penetrate it easily. When BT tanks are hit, they burn quickly. The gasoline engines are fire hazards. The BT tanks see more extensive action at Khalkhin Gol in 1939, fighting against Japanese forces in Mongolia. This is a larger conflict, involving hundreds of tanks in major battles. The BT tanks again prove their mobility value. Soviet commander Georgy Zhukov uses them aggressively, conducting sweeping maneuvers that encircle Japanese forces. The speed of the BT tanks is crucial to these operations. But again, armor is a problem. Japanese anti-tank guns destroy BT tanks in significant numbers. The crews are brave, the tactics are sound, but the vehicles are too lightly protected. Soviet tank designers learned the lesson. Speed is crucial, but it's not enough. The next generation of Soviet tanks needs to combine Christie's mobility with heavy armor and a powerful gun. It needs to be fast, tough, and deadly. In 1937, a design team led by Mikhail Koshkin begins work on exactly that tank. They call it the A-32, later redesignated as the T-34. Koshkin is a dedicated engineer, a true believer in the Soviet system, and a man who understands that the next war will be won by whoever builds the best tank. Born in 1898 to a peasant family, he represents the new Soviet technical elite. Educated under the Soviet system, promoted based on ability, utterly committed to building socialism. He's worked his way up through the Soviet industrial hierarchy, proving himself as a capable designer and manager. Now he's been given the most important tank project in the Soviet Union. Koshkin takes Christie's suspension as his starting point, but he's not just copying. He's synthesizing ideas from multiple sources. He studies the BT series and understands their strengths and weaknesses. He examines captured foreign tanks. He reads Western technical journals. He consults with Red Army officers about what they need in combat. He's taking the best ideas from multiple sources and combining them into something new. The T-34's suspension is based on Christie's system: large road wheels, independent suspension, excellent cross-country mobility. But Koshkin makes it more robust, more suitable for mass production in Soviet factories. He simplifies some of Christie's more complex features. He makes the suspension easier to maintain in field conditions. He fits the tank with wide tracks, crucial for operating in Russian mud and snow. The wide tracks distribute the tank's weight, reducing ground pressure and preventing the tank from bogging down in soft terrain. But the real innovation is the armor. Koshkin and his team angle the armor plates, a revolutionary concept that makes the steel more effective by causing shells to deflect rather than penetrate. A shell hitting angled armor has to travel through more steel than the plate's actual thickness. A 45-degree slope effectively doubles the armor's protective value. The T-34's frontal armor is 45 millimeters thick, but angled at 60 degrees from vertical, giving it the protective equivalent of 90 millimeters of vertical armor. No tank in 1939 has armor this effective. The T-34 mounts a 76.2 millimeters gun, the same caliber used in Soviet field artillery. It's more powerful than anything on German tanks in 1939. The German Panzer III mounts a 37-millimeter gun. The Panzer IV has a short-barreled 75-millimeter designed for firing high-explosive shells at infantry, not armor-piercing rounds at tanks. The T-34's gun can destroy any tank in the world at ranges where enemy tanks can't penetrate the T-34's armor. Koshkin chooses a diesel engine instead of gasoline. Diesel is less flammable, addressing one of the BT series' major weaknesses. It's also more fuel-efficient, giving the T-34 longer range. The V2 diesel engine produces 500 horsepower, giving the 26-ton tank excellent mobility. The combination of powerful engine, Christie suspension, and wide tracks makes the T-34 highly mobile across all terrain types. The result is a masterpiece of design. The T-34 combines mobility, armor, and firepower in a way no tank has before. It's not perfect. The early models have poor visibility. The commander has to operate the gun as well as command the tank, an overwhelming workload. The transmission is rough, difficult to shift, prone to failure. The interior is cramped and uncomfortable, but the fundamental design is brilliant. It's a tank that can outrun, outgun, and outlast almost anything on the battlefield. In 1939, prototypes undergo testing. The trials are extensive and demanding. The tanks are driven thousands of miles across varied terrain. They're fired at with various weapons to test the armor. They're pushed to their mechanical limits. The design team makes continuous refinements based on test results. But the basic concept proves sound. Koshkin personally leads a winter test drive from Kharkov to Moscow and back, over 1,200 miles in brutal conditions. It's March 1940, and the weather is terrible. Snow, ice, freezing temperatures. Koshkin wants to demonstrate the tank's reliability to Stalin and military leadership in the most dramatic way possible. He drives one of the prototypes himself, leading a small convoy. The journey is grueling. The tanks break through ice on frozen rivers. They struggle through snowdrifts. They endure mechanical problems in harsh weather. But they make it. Koshkin and his team arrive in Moscow and demonstrate the T-34 to Soviet leadership. Stalin is impressed. Military officials are impressed. The tank is approved for production. But the journey has cost Koshkin his health. Exposed to freezing temperatures for days, he develops pneumonia. His condition worsens over the following months. He dies in September 1940, at age 42, from complications of the illness. He never sees his creation in combat. He never knows that his tank will help save the Soviet Union. But his design is approved, and production begins. By June 1941, when Germany launches Operation Barbarossa, the Soviet Union has produced approximately 1,000 T-34s. It's not enough to stop the German invasion. The Red Army has over 20,000 tanks, but most are obsolete models like the T-26 and BT series. The T-34s are scattered across various units, often without proper training or support. Many are lost in the first weeks of the war due to mechanical breakdowns, lack of fuel, or poor tactics rather than German action. But it's enough to give the Wehrmacht the shock of their lives. June 22, 1941. 3 million German soldiers pour across the Soviet border in the largest invasion in military history. Operation Barbarossa is Hitler's gamble to destroy the Soviet Union in a single overwhelming blow. The plan is ambitious. 3 army groups will drive deep into Soviet territory, encircling and destroying the Red Army in a series of massive battles near the border. German military planners expect victory in 6 to 8 weeks before winter arrives. They have reason for confidence. The Wehrmacht has conquered Poland in weeks, France in months. Their blitzkrieg tactics are proven. Their army is experienced, well-trained, and equipped with what they believe is the best military technology in the world. German tank forces spearhead the invasion. Panzer divisions race ahead of the infantry, encircling Soviet armies, capturing cities, driving deep into Soviet territory. The Panzer III, armed with a 37mm or 50mm gun, is Germany's main battle tank. Over 1,400 are committed to Barbarossa. The Panzer IV, with a short-barreled 75mm gun designed for infantry support, provides fire support. Together, they've dominated every battlefield in Europe. German tank commanders are confident, almost cocky. They've faced Polish tanks, French tanks, British tanks. They've won every time. Soviet tanks are expected to be inferior, poorly maintained, badly led. The first weeks of Barbarossa seem to confirm German expectations. Soviet forces are caught off guard, poorly deployed, badly led. Stalin's purges in the late 1930s have killed many of the Red Army's best officers, including innovative thinkers like Tukhachevsky. The remaining commanders are often incompetent, promoted for political loyalty rather than military skill. Soviet tanks are destroyed by the hundreds, often without firing a shot. Many are abandoned when they run out of fuel. Others are lost to mechanical breakdowns. German forces advance at a staggering pace, capturing hundreds of thousands of prisoners. Victory seems inevitable. German soldiers write letters home, saying the war will be over by Christmas. But then the Germans start encountering something unexpected. Reports come in from the front lines. Strange tanks, fast tanks, tanks that German guns can't penetrate. At first, the reports are dismissed as battlefield confusion or exaggeration. Every war produces wild stories, but the reports keep coming, and they're getting more alarming. Tank commanders are reporting that their guns are ineffective. Infantry units are calling for air support because their anti-tank weapons don't work. Something is wrong. The Battle of Brody, late June 1941, is one of the largest tank battles in history. Soviet mechanized corps attempt a counterattack against German forces in western Ukraine. It's a disaster for the Soviets. Poor coordination, inadequate fuel supplies, communication breakdowns, and German air superiority lead to massive losses. Over 800 Soviet tanks are destroyed or abandoned. It appears to be another German victory. But in the chaos of battle, German tank crews experience something that shakes their confidence to its core. A German Panzer III commander spots a Soviet tank approaching his position. It's moving fast, faster than any tank he's seen. The silhouette is unfamiliar, with sloped armor that looks strange compared to the boxy Soviet tanks he's encountered before. He orders his gunner to fire. The 50mm armor-piercing round strikes the Soviet tank's frontal armor dead center. It bounces off, ricocheting into the sky. The gunner fires again, aiming carefully. Another ricochet. The Soviet tank doesn't slow down. It doesn't even seem damaged. It rotates its turret with mechanical precision and fires once. The German tank is destroyed, its thin armor no match for the 76.2mm shell. This scene repeats across the battlefield. German tanks that have dominated Europe suddenly find themselves outmatched. The T-34's sloped armor is revolutionary. Instead of presenting flat surfaces that shells can penetrate, the angled armor causes rounds to deflect. The physics are simple but devastating. A shell hitting at an angle has to travel through more armor than the plate's actual thickness. The deflection also reduces the shell's effective energy. German 37mm and 50mm guns, which have been adequate against Polish and French tanks, are nearly useless against the T-34's frontal armor. Only lucky shots hitting the thinner side or rear armor can penetrate. And it's not just the armor. The T-34's 76.2mm gun can destroy any German tank at ranges where German guns can't even penetrate the T-34. A T-34 can engage German tanks from 1,000 meters or more, staying outside the effective range of German guns. The T-34's mobility, thanks to Christie's suspension, allows it to outmaneuver German tanks, choosing engagement ranges and positions. When a T-34 crew knows what they're doing, when they have fuel and ammunition, when they're properly supported, they're nearly invincible. The Battle of Raseiniai, also in late June 1941, provides another shock to German forces. A single Soviet KV-1 heavy tank, even more heavily armored than the T-34, holds up an entire German division for a full day. The KV-1 isn't based on Christie's design, but it shares the T-34's philosophy of heavy armor and powerful armament. The tank is positioned on a road, blocking the German advance. German forces throw everything at it. Panzer guns fire repeatedly. Anti-tank guns engage from multiple angles. Even 80mm anti-aircraft guns, the most powerful weapons available, are brought up. The KV-1 is finally stopped, but only after sustaining dozens of hits. The psychological impact on German forces is enormous. If one Soviet tank can do this, what happens when they face hundreds? What happens when Soviet industry starts producing these monsters in quantity? German commanders send urgent reports to headquarters. The reports are alarming, almost panicked. They describe Soviet tanks that are immune to German weapons. They request immediate reinforcements, better anti-tank guns, air support. General Heinz Guderian, the architect of German blitzkrieg tactics and one of the most respected tank commanders in the world, personally inspects captured T-34s. He's impressed and alarmed. The design is superior to German tanks in almost every way. In his memoirs written after the war, he acknowledges the T-34's superiority, calling it a nasty surprise and admitting that German tanks were outmatched. General Ewald von Kleist, commanding the 1st Panzer Army, is even more direct. He later calls the T-34 the finest tank in the world. German after-action reports describe the T-34 as invulnerable from the front and recommend avoiding engagement unless German tanks can attack from the sides or rear. Tank commanders develop new tactics, try to lure T-34s into ambushes, attack from multiple directions simultaneously, use terrain to get close enough for flank shots. These tactics work sometimes, but they're desperate measures, adaptations to a problem that shouldn't exist. This is not what German high command expected. They expected technological superiority. They expected their tanks to dominate, as they had in Poland and France. Instead, they're facing a Soviet tank that's better than anything Germany has. It's a strategic crisis. The entire Barbarossa plan assumes quick victory, achieved before Soviet industry can fully mobilize. But if Soviet tanks are superior, if German forces can't achieve the rapid breakthroughs they need, if the war drags into winter, the entire invasion could fail. German forces adapt tactically. They learn to use their 80mm anti-aircraft guns in anti-tank roles. The 80mm, originally designed to shoot down aircraft, can penetrate T-34 armor at reasonable ranges, but it's a large, cumbersome weapon, difficult to conceal and deploy quickly. It requires a crew of 10 men. It's vulnerable to artillery and air attack. It's not a solution, just a stopgap. German tank crews learn to work in teams, trying to flank T-34s and hit their thinner side armor. One tank distracts from the front, while others maneuver for side shots. German infantry receive better anti-tank weapons, including magnetic mines and shaped charges. Combat engineers use mines and explosives. These tactics work, but they're desperate measures, adaptations to a problem that shouldn't exist. The strategic response takes longer but is more fundamental. German tank designers are ordered to create new tanks that can match the T-34. The Panther tank, which enters service in 1943, is directly influenced by the T-34. It has sloped armor, copying the T-34's most effective feature. It has a powerful 75mm gun that can penetrate T-34 armor. It has improved mobility. German engineers essentially admit that the T-34's design philosophy is correct and create their own version. The Tiger tank, with its massive 80mm gun and heavy armor, is rushed into production. It's a different approach, emphasizing firepower and protection over mobility, but it's still a response to the T-34 threat. Germany's entire tank development program is reorganized around the threat posed by the T-34. But here's the bitter irony that German commanders don't know, that won't be fully understood until after the war. The tank that's destroying their panzers, the tank that's forcing Germany to redesign its entire armored doctrine, the tank that might cost them the war, was designed by an American engineer. An engineer whose own country rejected his ideas as impractical. An engineer who was forced to sell his design to the Soviets because America wouldn't buy it. The suspension system that allows the T-34 to move so fast across rough terrain The system that's crucial to its effectiveness was invented in a workshop in New Jersey and rejected by the U.S. Army as too radical. J. Walter Christie, working in his cluttered workshop, created the foundation of the weapon that's now terrorizing the Wehrmacht. The U.S. Army, which rejected his designs as too fast, too unconventional, too different from established doctrine, is now watching those same designs, refined and produced by the Soviet Union, defeat their German enemies. The technology that America threw away has become the Soviet Union's greatest weapon. And Christie himself, still alive in 1941, still trying to sell his designs to an uninterested American military, probably doesn't fully understand the impact his work is having on the Eastern Front. The T-34 doesn't win the war by itself. Soviet victory comes from many factors. Vast manpower reserves that allow the Red Army to absorb catastrophic losses and keep fighting. Industrial capacity that produces weapons in quantities Germany can't match. Strategic depth that trades space for time. Brutal determination at every level from Stalin down to individual soldiers. German strategic mistakes, including Hitler's interference in military decisions, and the harsh Russian winter that German forces are unprepared for. But the T-34 is crucial. It gives Soviet forces a technological edge they desperately need. It allows them to trade blows with German armor and come out ahead. It enables the mobile warfare that eventually pushes German forces back across Eastern Europe. Production numbers tell the story of Soviet industrial might and the T-34's importance. The Soviet Union produces over 84,000 T-34s during the war, making it the most produced tank in history. Factories across the Soviet Union, many relocated beyond the Ural Mountains to escape German advance, churn out T-34s by the thousands. Workers labor in unheated factories during brutal winters, often working 16-hour shifts, producing the tanks that will save their country. Women, teenagers, and elderly workers replace men sent to the front. Quality sometimes suffers. Early war T-34s are often poorly finished, with rough welds and imprecise tolerances. But they work. They're reliable enough, and there are so many of them. German factories, despite frantic efforts, can't match Soviet output. The Panther is arguably a better tank than the T-34 in some ways, with superior optics, better crew ergonomics, and more accurate gun. But Germany only produces about 6,000 Panthers during the entire war. The Tiger is fearsome, nearly invulnerable from the front, capable of destroying any Allied tank at long range. But it's complex, expensive, and difficult to produce. Fewer than 2,000 Tigers are built. Germany simply can't produce enough tanks to replace losses. Soviet factories produce T-34s faster than German forces can destroy them. The T-34 evolves during the war. Combat experience reveals weaknesses that are addressed in later models. The T-34-85, introduced in 1944, has a larger turret with room for 3 crew members instead of 2. Allowing the commander to focus on commanding rather than operating the gun. It mounts an 85-meter gun, more powerful than the original 76.2 Mir, allowing it to better combat German Tigers and Panthers. Visibility is improved. The transmission is refined. But the basic design, the fundamental concept, remains Christie's. Large road wheels, independent suspension, excellent mobility. The convertible track feature, the ability to remove tracks and drive on wheels, is dropped as impractical in combat conditions. But the suspension system that made it possible remains the tank's foundation. J. Walter Christie dies in January 1944 in Falls Church, Virginia. He's 79 years old. He's never wealthy, never fully recognized by his own country for his contributions. The U.S. Army has finally started using some of his ideas. The M18 Hellcat tank destroyer, which enters service in 1943, uses a Christie-style suspension and is the fastest tracked armored vehicle of the war. The M18 can reach 55 miles per hour, vindicating Christie's emphasis on speed. But it's too little, too late for Christie to see full vindication. He dies knowing that America rejected him, but probably never fully understanding the impact his designs had on the war raging across Europe and Asia. The historical irony is almost too perfect to believe, almost too neat to be true, but it is true. An American engineer, rejected by American military bureaucracy, sells his design to the Soviet Union against his government's wishes. The Soviets, recognizing the design's value in a way American officials didn't, develop it into a war-winning weapon. That weapon terrorizes German forces, forcing Germany to divert resources into developing countermeasures. The Eastern Front, where the T-34 proves decisive, becomes the graveyard of the German army. Over 80% of German military casualties occur fighting the Soviets, and the tank that inflicts much of that damage, the tank that helps turn the tide of the largest war in history, is based on a design that started in New Jersey and was rejected as impractical. What if the U.S. Army had adopted Christie's designs in the 1920s? What if America had entered World War II with fast, mobile tanks based on Christie's suspension? It's impossible to know for certain, but we can speculate. Would American armored divisions have been more effective in North Africa, where mobility was crucial in desert warfare? Would the breakout from Normandy after D-Day have been faster with more mobile tanks? Would American forces have suffered fewer casualties if they had better tanks? The M4 Sherman, America's main battle tank during the war, was reliable and produced in huge numbers, but it was outgunned by German tanks. American tank crews often faced Tigers and Panthers with inferior weapons. If they had tanks based on Christie's designs, would the war have been shorter? We can't know. History doesn't offer alternative timelines. But we know this: the Soviet Union recognized the value of Christie's work when America didn't. They invested in it, developed it, refined it, and used it to help win the largest war in history. They saw potential where American officials saw problems. They embraced innovation where American bureaucracy preferred convention. The T-34's influence extends far beyond World War II. After the war, the Soviet Union exports T-34s to allied nations around the world. The tank becomes a symbol of Soviet military power and a tool of Soviet foreign policy. T-34s are sent to North Korea, China, Eastern European nations, Middle Eastern countries, African nations, anyone aligned with the Soviet bloc. The tank sees combat in the Korean War, where it proves effective against early American tanks like the M24 Chaffee. American forces rush the M26 Pershing heavy tank to Korea, specifically to counter T-34s. T-34s fight in the Middle East, in the Arab-Israeli Wars of 1967 and 1973. They fight in Africa, in various post-colonial conflicts. They fight in Asia, in Vietnam, and other regional wars. Some T-34s remain in service into the 21st century, over 60 years after the design's introduction. As late as the 1990s, T-34s see combat in the Yugoslav wars. It's one of the most successful weapon systems ever created, measured by longevity, production numbers, and combat effectiveness across decades. Tank designers worldwide study the T-34 after the war. Its combination of mobility, armor, and firepower becomes the template for post-war tank design. The sloped armor concept becomes standard on virtually every tank designed after 1945. The emphasis on reliability and ease of production influences military procurement decisions. The T-34 proves that the best tank isn't necessarily the most sophisticated or the most powerful, but the one that combines good enough performance with reliability, ease of production, and suitability for mass deployment. Christie's suspension system influences tank design for decades after his death. Various nations adopt Christie-style suspensions or derivatives. The British Crusader tank uses a Christie suspension. The Swedish S-tank, a unique turretless design from the 1960s, uses a modified Christie suspension. Even modern tanks owe something to Christie's innovations in suspension design. The basic principle he pioneered, large road wheels with independent suspension for better cross-country mobility, remains relevant in contemporary armored vehicle design. But the larger lesson is about innovation and institutional resistance to change. Christie was difficult, yes. His designs had problems, yes. His prototypes were sometimes unreliable. He was hard to work with, argumentative, unwilling to compromise. But his fundamental vision was correct. He saw that future warfare would require speed and mobility. He understood that tanks needed to be more than slow-moving bunkers. He was right, and the institutions that rejected him were wrong. Military organizations, by their nature, tend toward conservatism. They prefer proven designs over experimental ones. They value reliability over innovation. They want contractors who follow specifications, not visionaries who argue about doctrine. These tendencies exist for good reasons. Military equipment needs to work reliably in combat. Soldiers' lives depend on it. Experimental designs can fail catastrophically. The cost of failure in military equipment is measured in lives lost. So caution is understandable, even necessary. But conservatism has costs. Sometimes the radical idea is the right idea. Sometimes the difficult engineer is the genius who sees what others miss. Sometimes the design that seems impractical is actually revolutionary. The challenge for military institutions is distinguishing between genuine innovation and impractical fantasy, between visionary thinking and crackpot schemes. It's not an easy distinction to make. Christie's designs did have real problems, but the Army focused on the problems and missed the revolutionary potential. The U.S. Army's rejection of Christie wasn't entirely irrational. His designs did have reliability issues. His prototypes were expensive. He was genuinely difficult to work with. But the Army's decision-making process was too rigid, too focused on immediate practicality, too dismissive of long-term potential. They saw the problems with Christie's designs, but missed the revolutionary implications. They let bureaucratic convenience override strategic vision. They chose contractors who were easy to work with over an engineer who was right about the future. And there's another lesson about technology transfer and unintended consequences. When Christie sold his designs to the Soviet Union, he was just trying to survive financially. He needed the money. He was frustrated with American rejection. He probably didn't think much about the strategic implications. He was an engineer, not a geopolitical strategist. The U.S. government disapproved but didn't stop the sale. Nobody imagined that this transaction would lead to the T-34, to German defeats on the Eastern Front, to the shape of World War II and the post-war world. Technology doesn't respect borders or intentions. A design rejected in one country can be adopted and perfected in another. An innovation dismissed as impractical can become a war-winning weapon in the hands of people who recognize its value. The flow of ideas and technology across borders can have consequences nobody predicts. In 1930, selling tank designs to the Soviet Union seemed like a minor commercial transaction. By 1945, it had helped shape the outcome of the largest war in history. The story of J. Walter Christie and the T-34 is ultimately a story about vision and blindness, about genius and bureaucracy, about how history turns on decisions that seem minor at the time. It's about an engineer who saw the future of warfare and couldn't convince his own country to listen. It's about a design that traveled from New Jersey to Moscow to the battlefields of Eastern Europe, changing form, but retaining its essential genius. It's about a tank that terrified the German army and helped win the largest war in history. And it's about the bitter irony that sometimes the most dangerous weapon isn't the one you build. It's the one you refuse to build, the one you reject, the one you let slip through your fingers into the hands of someone who understands its value. The U.S. Army rejected Christie's designs as too radical, too impractical, too different from established doctrine. Those same designs, refined and produced by the Soviet Union, became one of the most successful weapons in military history. In July 1941, when that German panzer commander watched his shells bounce off a T-34's armor, when he radioed headquarters in panic, when he realized his tank was obsolete and his life was in danger, he was experiencing the consequences of decisions made years earlier in American procurement offices. He was facing the result of bureaucratic conservatism, of institutional resistance to innovation, of a genius rejected by his own country and embraced by another. He was facing J. Walter Christie's revenge, delivered through Soviet factories and Soviet tank crews, and he never even knew it. He never knew that the tank destroying his Panzer began in a workshop in New Jersey. He never knew that an American engineer, rejected and dismissed, had created the weapon that was killing him. He just knew that he was outmatched, outgunned, and terrified. And that terror, multiplied across thousands of German tank crews over 4 years of brutal warfare, helped determine the outcome of World War II. If you found this story as fascinating as I did, make sure to hit that subscribe button and join our community of history enthusiasts. We dive deep into the untold stories, the rejected geniuses, and the unexpected twists that shaped our world. Drop a like if you enjoyed learning about J. Walter Christie and his incredible tank design that changed the course of World War II. And I'd love to hear your thoughts in the comments below. What other rejected innovations do you think changed history? Can you imagine how different the war would have been if America had adopted Christie's designs? Your support means everything and helps us bring more incredible historical stories like this one. So subscribe, hit that notification bell, and let's explore history together. Thanks for watching, and I'll see you in the next video.